let's have a look at standard IPv4 numbered ACLs. So this entire network has been pre-configured. So basically what we're going to try and do is we are going to try and control the connectivity between this device over here, which is 10.2, and these devices over here, which are 20.2 and 20.3. Okay, so let's just go into this PC. Let's go to desktop. Let's go to command prompt. Now you will have heard me say this a few times. If you want to do extra things, like say for instance ACLs, the first thing you should do is to make sure whether the network actually works before applying these things. If you don't do that first, you don't actually know what you're troubleshooting. Are you troubleshooting ACLs that aren't working, or are you troubleshooting a network that isn't working? So let's just see if we can actually ping those two devices beforehand. Okay, so we can reach the PC, which is 20.2. Let's try the server. Okay, fantastic. So we can also reach the server. So that part is sorted. Now, next up, let's decide what we're going to do. So obviously in the real world, you'll have to let the scenario or the specifications guide you. But let's say, for instance, we decide that this PC over here is only allowed to access the server on this network and not allowed to access any of the other devices on this network. Okay, what would be required to do that? Okay, so firstly, a general rule of thumb is with standard ACLs, because we only know who the source of the traffic is, in this case, a device on this network, and we don't know who the destination is, we actually have to provide sort of the destination by putting the ACL as close to the destination of the traffic as possible. Now, that's actually open for interpretation, and there isn't a strict right or wrong. There's really, where does it have the best impact on filtering what you want to filter, and also the best impact insofar as not slowing down your traffic. So basically we have to make a decision. Now, firstly, before we get to the actual interfaces which will be involved in this, it's clear to see that the device that is closest to this network is this router over here. So let's go into its config, and this is the branch router, and now we can go and configure our access control list. Okay, so what does an access control list do? An access control list, we've seen it can permit and deny, and specifically for a standard ACL, it's going to be just on the source of the traffic. So what we want to do is, let's take a look at our options. You'll see right at the top of our list, we have a command called access list. Okay, so access list. Now then we need to provide it with a number. Now, if we provide it with a number in the range 1 to 99, it is going to be a standard access list. If it is in the range 100 to 199, it's going to be an extended access list. So we need to give it a number in the range 1 to 99. Okay, so let's say we are making an access list 1. The next thing we need to do is we need to deny, permit, or remark. So deny specifies which packets to reject, permit specifies packets that may be allowed through, And remark is basically just a comment or a description. Okay, so let's say we want to permit, and what do we want to permit? We want to permit any traffic from this network over here, the 192.168.10.0 network. We want to permit traffic into this network. Okay. So let's say permit 192.168.10.0 0.0.0.0.255. Okay, so that is going to permit traffic from that entire network. Okay, now can you see that there is let's call it a limitation that we have arrived at for standard access lists? It only allows us to filter on a source. So can we actually do what we set out to do? Can we filter traffic from being able to go specifically just to the server? No, not really. We can't. So we can't actually, on a standard ACL, deny traffic from going to a specific device. So all we can do is we can permit traffic from a specific network, and we can deny traffic from somewhere else. So let's say we want to deny any traffic from this network over here. But what we're going to do is we are not going to permit everything from this network. We are only going to permit traffic from that specific host. Now this specific host is 30.2. So we'll add that statement, and then we'll say access list 1 permit, and what we'll permit is 192.168.30.2, and this is now a specific host device. So we can either type out a host mask, or we can simply say permit host 192.168.30.2. Okay, so what will that do? It will only permit that specific host address through the access list. Again, it won't specify where this host traffic is allowed to go to on that specific network. It simply says that the traffic is allowed from this host. Now, at this stage, the access list is basically done. But there's something that you have to realize. The only devices who will be able to access this specific network are actually devices who are on the 10.0 network or on the 30.0 network, but specifically have the host address of 30.2. The reason for that is that at the end of any access list, any standard ACL, there is an implicit, in other words, it's there without you configuring it, statement that says deny any. So in other words, if you do not have a statement that at least permits some traffic through, then basically you're denying everything. So if I just had a deny statement up here in my access list, it would have basically been useless, because for the simple fact, once you create an access list, it always ends in a deny. So if you want to circumvent that, if you say, for instance, have an access list that just denies certain things, and then you want to permit anything else, you have to end it with the statement permit any. Because once a certain statement is triggered in an ACL, it will not read statements after it. So in other words, this permit any will always trigger. That means it will never have the chance to hit the deny any that is actually at the end of this access list. But okay, we don't want to do that now. We just want to allow the things that we are allowing. Okay, so if you want to see your access list, you can do a show run. And there we can see down here we have access list 1, which permits everyone from the 10.0 network, and it also permits that specific host. And again, as we've noticed, we set out with lofty goals and ideals to permit traffic to the specific server, but we soon realized it's a bit difficult to do if you're only using standard access lists. So technically, you can go and put the server on its own network. There are things that you can try and do to have more than one access list on different interfaces, that the one lets certain traffic through and the other one denies certain things. But we don't want to do this. The only reason I mentioned the server is to show you that at a default, the standard ACLs won't allow us to just do a simple statement that blocks or permits specific traffic to a specific device. We can only really filter traffic on where it's coming from its source. Okay, now that being said, we're not done yet. So what we need to do is we need to go into this interface over here. So that gig00 interface, that is the closest interface to the destination, because remember, the rule of thumb says put your standard ACL the closest to the destination of the traffic. Now the destination of the traffic is this network. So in other words, we need to put it on that interface. Now where is the traffic coming from? The traffic is coming from over here and from over here. So to get to this network, the traffic needs to flow out of this interface into the HR network. So we need to apply the ACL on the gig00 interface in an outbound direction. So let's go and do that. So to do that, we simply go into int gig00, and then you'll see we can go and apply it as follows. We say IP, and then you'll see there's a command access group. And then lastly, it expects you to provide a number. So this is the same command for standard or extended, or a word if you're using named access lists. And the named access list we'll see when we do IPv6. So IP access group, and just remember the IPv6 command is actually, you'll see, is slightly different for applying an access list. But I just want to mention that we will do named access lists. We're just not going to do it for IPv4. We will do named access lists for IPv6. So IP access group, and again, just to clarify myself, I don't mean we're not going to do it. If you read through the content, you'll see that we do it. I just mean that our example, our practical example, is just going to be numbered for the IPv4 ones, and it's going to be named for IPv6, since it's the only option available for IPv6. But I digress. Let's say IP access group, and our access list was number 1, and then we need to specify whether it filters inbound or outbound, and we said it must filter out. Okay, so fantastic. So this now says we should still be able to ping. Okay, so let's go back over here. Our pings should still work. Okay, so fantastic. That is still working because we say we allow any traffic from this network. Let's try pinging from this PC. So let's say ping 192.168.20.3. Okay, fantastic. That works as well. And then now let's go and change this PC's IP address. Let's give this PC the IP address of .3. And then we repeat our ping. And what can we see? All of a sudden, it says destination host unreachable. Because remember, according to our access list, it said we are not allowed to ping from this network except for the address 30.2. So we changed the address to 30.3, and now you see the access list works. We can go and change it back again just to show you 30.2. Let's do the same ping again. And there you can see, like magic, our ping works again. So that's the basics behind configuring an IPv4 numbered standard access list. What you have to remember is, firstly, standard access lists only filter on the source of the traffic, not on specific protocols and not on the destinations of the traffic. Secondly, we place them closest to the destination of the traffic to be filtered because we don't know what the destination is. You'll see in time that extended ACLs are going to be the one that we're going to use if we want to filter traffic to a specific destination, or when it's traffic for a specific protocol or type of traffic.